Okay, so similar to the previous video, I'm going to give you a series and then ask you to work backwards to find the original function. Okay, so this one's quite tough. I don't expect you to be able to do this, but maybe you might want to have a go for yourself. So maybe you might want to press pause and have a go. Okay, so it's a bit hard to recognize which one you should use. Looking at this, it's actually quite hard. I'm just going to give you lots of examples, and then hopefully over time you will gain some experience, and then you will have a gut feeling of knowing what to do. So for this one here, rewrite it as this. So now you can see that this is a constant. You've got a constant in here. It's 1 over a third. That's your constant. So move this constant 1 over a third out here. So that will then give you this. That will then give you this. And then now notice that, well, you've got to the power of n, to the power of n, to the power of n. So merge everything together into one fraction. So now you should be able to tell, you should be able to recognize that that this here is a bubble to the power of n. So this is a bubble to the power of n. There's no alternating component, so we should be using this. So here you simply got a bubble to the power of n. Here you've got a bubble to the power of n. So you should be using this. Well, work backwards. That will then give you this function here. So from here, it will be a third times this thing here. So it will be a third. It will be a third times this thing here. Well, don't forget this is our bubble here. This is our bubble. Our bubble is negative whatever's in here. Okay, so from here, that will then take us to here. So now it's just a matter of tidying this up. So tidy this up. That will then give you this, and then that will then give you this. So after all that, this series represents 1 over x. Okay, so now you've got to consider the values of x for which it's valid for. So hang on, going back to here. Hang on. So it's valid for the absolute of the bubble, to be less than 1. So we require the bubble, the absolute of the bubble, to be less than 1. So hang on. So looking at the bubble, looking at the bubble here, this is our bubble here. We require the absolute of this to be less than 1 because of this bit here. So we require the absolute of this. So we require the absolute of this to be less than 1. You're taking the absolute, so you don't really need this negative here. Yeah. So now times both sides by 3. That will then give you this. Add both sides, blah blah. So it's valid for x being greater than negative 6 but smaller than 6. Okay.